Hello everyone, in this video I'm going to show how to use Analytic solver to develop Ensemble classification tree model using the HELOC dataset that we have already used in the previous examples. First click on data mining and then partition and choose standard partition. Make sure that the correct dataset is selected here and move age, sex, income and HELOC under selected variables. As the Ensemble tree modeling process doesn't involve pruning, only the train and validation datasets are needed for constructing the model and evaluating the model's performance. Select Pick up rows randomly and then check Set Seed checkbox to use the default random seed of 1, 2, 3, 4, 5. Select Specify percentages to allocate 60% and 40% of data to training and validation sets respectively, and then click OK. With the STD partition worksheet active, choose Data Mining, Classify, and then Ensemble, and then here Bagging. In the Data tab, move the predictors Age and Income under selected variables, sex under categorical variables, and HELOC under output variable. Accept other defaults and click Next. In Parameters tab, select Decision Tree from the pull-down menu for weak learner. Accept other defaults and click Next. Analytic solver will construct 10 decision trees as the weak learners and uses the bagging technique for the Ensemble tree model. In the Scoring tab, check the Summary report for training and validation data, and also check the lift charts for validation. Check the In Worksheet box, and under New Data WS tab, select HELOC score. These 20 records of new bank customers in data range A1 to C21 will be scored by the Ensemble tree model. Make sure the first row contains headers box is checked and click Match by Name. Accept other defaults and click Finish. To assess model performance, we return to Validation dataset, and here under Classification Summary, you can see the performance measures. The performance measures show that the Ensemble model yields an overall misclassification rate of 21.5%, sensitivity of 0.6735, and specificity of 0.8212. Recall that the single classification tree in the previous videos has a misclassification rate of 23% and sensitivity of 0.5385 and specificity of 0.8514. The current Ensemble tree model has slightly better overall predictive performance, a higher sensitivity rate, and performs better at correctly identifying Class 1 cases, which are customers who respond to HELOC offer, than the single classification tree model. Remember that the performance measures that we calculate here are calculated based on the cutoff value of 0.5. Lowering the cutoff value will classify more cases into the target class, resulting in different performance measurement values. Therefore, in order to evaluate model performance, I recommend that you inspect the cumulative lift chart, the decile-wise lift chart, and the ROC curve because they are independent of the cutoff value. Here on the screen, you see the three charts. The cumulative lift chart shows that the blue line lies well above the red diagonal line. Therefore, the Ensemble tree performs considerably better in terms of predicting whether or not a potential customer will respond to the HELOC offer. For example, if we send HELOC offers to 100 bank customers, which is the half of the validation data sample size, who have the highest predicted probability of responding to the offer, we will be able to reach 42 out of 49 customers, which is 85.71%, who actually respond to the offer. Alternatively, if we send the offer to 100 randomly chosen customers, we would reach only 50% of the customers who actually respond to the offer. The next figure shows a decile-wise lift chart. The first 10% of potential customers selected by the Ensemble tree include 1.84 times as many customers who would respond to the HELOC offer compared to a random selection of 10% of potential customers. And finally, the last figure is the ROC curve. ROC curve shows that the Ensemble tree performs much better than the baseline model in terms of sensitivity and specificity across all cutoff values. The area under the curve is 0.8008, which is closer to optimum classifier, and if you recall that optimal classifier is 1, and compared to a random classifier, in that case, AUC of the random classifier is 0.5. Overall, the Ensemble model demonstrates slightly better predictive than the single tree classification model. In the cbagging_new score worksheet, the new bank customers are scored. The prediction hello column displays the classification results for each of the 20 observations. The first potential customer on the list is classified as not likely to respond to the hello offer, while the fifth potential customer is likely to respond. To create an ensemble tree model using the boosting strategy, you can repeat the previous procedure while the STD partition worksheet is active. Choose data mining, classify, ensemble, and boosting. Everything is the same except here, parameters tab, you need to select one boosting method, and Analytic Solver offers 3 variants of auto boost algorithm. And to create an ensemble tree model using the random forest strategy, you can repeat the same steps while choosing classify, here ensemble, and random trees. Here in the parameters tab, the default number 2 for the number of randomly selected features indicates that 2 predictor variables will be randomly selected to construct each tree. You check the show feature importance and then accept other default settings and then click finish. This is how to use Analytic Solver to develop an ensemble classification tree.